Smart contract hacking is one of the most lucrative in-demand skills in the Web 3.0 space. We've seen billions of dollars compromised inside of smart contracts in the DeFi ecosystem over the past few years, and there's a tremendous opportunity in this space to acquire the skills to hack smart contracts, okay? So not so that you can take money for yourself, but so that you can see these things, protect yourself, and also help other people so that we can move this space forward, and as a win-win, you can be handsomely rewarded. So in this video, I want to teach you about a special smart contract hacking technique surrounding Solidity's special self-destruct functionality. I'm going to show you an exact step-by-step coding example on how this works. So before we get into that, if you're new around here, hey, I'm Gregory. On this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to master blockchain step-by-step start to finish, then head on over to dappuniversity.com/bootcamp to get started today. All right, so let's get into this. Let's talk about how you can hack smart contracts with the self-destruct function inside of Solidity, okay? So what is that? So self-destruct is a special function that's available to Solidity smart contracts that has a particular set of behavior. So essentially, self-destruct, what it's going to do is essentially kill a smart contract. It's going to remove all the bytecode from it, okay? Essentially deactivate it, all right? And whenever you call this function inside your smart contract, it's going to take any cryptocurrency that's contained in the contract and send it to a specified address, okay? So essentially, I'll show you what that looks like. If you have a smart contract like this, and it's got a lot of logic inside of it, you can have a function that looks like this, which is a function, end, okay? Just for a pseudocode example. And inside of that, we can call this special function called self-destruct. Okay, and if we call this, we say message.sender, pass it inside of there, it's going to essentially destroy this contract where it's really no longer usable. It's going to remove the bytecode, and it's going to send all the ether contained inside the smart contract to the specified address that you pass into this function. All right, so this is a way to essentially, soft remove smart contracts from the network. But this has potential side effects if you pass a smart contract address into here. So remember, there are different types of addresses on blockchain. There's externally owned account wallets, like if you have a MetaMask wallet, for example, and there's also smart contract addresses, and you can pass either one of those address types into this self-destruct function. Now, when you call self-destruct and you pass in a smart contract address, it's going to have an interesting set of behavior. So let me explain what that is. So essentially, we can move this down to an attacker contract, say contract attacker. All right. And whenever you pass the address of my contract down here, let's just say, my contract address. All right. And you call self-destruct, it's going to force on any ether that's sent in self-destruction to my contract. And this can cause many anomalies inside of these other contracts because, these contracts are supposed to have a receive function or a fallback function in order to receive ether. So example, function receive. All right, this is going to be a function that gets called whenever the contract receives ether. All right, so this is a requirement if you're going to send, ether to this contract directly or a fallback function. And you don't even have to have one of these functions on the smart contract for self-destruct to force an ether to it. All right, so that can cause some interesting behavior, which we're going to see in a minute. Also, if you have a receive function or a fallback function that has any business logic inside of here, all that business logic is going to get bypassed whenever you force send ether to a contract through self-destruct. So let's look at a concrete coding example of exactly how this could break another contract. All right, so I've put a link in the description below down to this coding repository where I have prepared a smart contract example that shows you how to hack another smart contract with a self-destruct function. So go ahead and download that, all right? And it doesn't matter if you do git clone or you download the code from a zip file. As long as you have the code here on your computer, just go ahead and enter into that directory with your terminal and do npm install to make sure you've installed all your project dependencies. Okay, we're going to use the hard hat smart contract development framework to write the smart contracts and also run the tests that illustrate this, okay? So once you've done that, go ahead and open up the project in your whatever text editor you'd like. I'm just using Sublime Text. That's my personal preference. And so you can see we got a package.json in here that's got all our dependencies. All right. And then we also have our contracts that illustrate this. So what I'm going to do is open up this file, this contract here, and then I'm also going to open up these tests. And I'm going to initialize these and actually build these out one by one so that you can see exactly how this works. All right, so inside of self-destruct.sol, I've created two smart contracts that are going to illustrate how this works, okay? So the first contract is going to be an NFT or an unfungible token. This is going to be a pseudo NFT contract because we're not going to build out an entire NFT. It's just outside the scope of this video. I've got plenty of videos on my channel if you want to see how to create an NFT from scratch. But I really want to illustrate why this is important, okay? So what we're going to do is have a fictional scenario where we have the pseudo NFT that lets other people mint the NFTs and create them from scratch. And where they call the mint function, they're going to pay Ether, okay? And then we're going to limit the amount of NFTs that are created by setting a fundraising goal, okay? So essentially what we're going to do is have this mint function like this. Say function mints public payable. Okay, so public means that we can call it out to the smart contract. That's the visibility. And payable is a built-in modifier Solidity that lets us send an Ethereum cryptocurrency or Ether whenever this function is called. So what we're going to do is require that this person is sending in the right amount. So each NFT is going to cost 1 Ether. We'll say require. Okay, message.value. That's a globally available variable inside Solidity that just determines how much cryptocurrency is sent in. This is going to be the way value. We'll say equals 1 Ether. Okay, so we'll say must send exactly 1 Ether. All right, and then next what we're going to do is essentially issue them an NFT. So that's going to be a pseudo process right here. We'll just say mapping uints. So that's going to be the ID of the NFT, and the address is going to be the owner who just purchased it. We'll say public owner of. Okay, so essentially what we're going to do is add their ownership right here. And we'll say total supply equals message.sender. Okay, so message value is the amount of cryptocurrency. Message sender is the person who's calling the function. And we're going to keep track of the total supply like this. Uint public total supply. All right, and then we'll simply increment total supply here to count the IDs. Okay, so now what we're going to do is set the fundraising goal. So essentially what we're going to say is once we've collected 100 Ether, we're not going to let people mint any more NFTs. So we can say, this, we can say require address this balance. So basically this is the current smart contract that we're coding inside of. Address just, type, just cast this to an address type, which check the Solidity balance like this. And we can make sure it's less than or equal to the goal. So we'll keep track of the goal here. We'll say uint public goal equals 100 Ether. All right, and so as long as 100 Ether has not been collected yet, we're going to let people continue minting NFTs. All right, so that's where the vulnerability comes into play. We're keeping track of this based on the balance of the Ether contained in the smart contract. Okay, that's what we're counting for right here. And so this can be exploited by an attacking smart contract using these self-destruct functions. So let me show you how that works. So essentially, we can create a contract called attack here, where somebody can essentially deploy the contract with the NFT address. So we'll do that like this. We'll just say constructor. This is the function that must run once and only once whenever the contract is deployed to the blockchain. And we just inject the address of this NFT contract right here. And we store it to a state variable like this. NFT is the type, is the contract type, and then we save it as a variable called NFT. And then inside of it, we can essentially have a function called attack where we use the self-destruct function like this. So we say attack is public and it's payable. So we're going to let the attacker send in Ethereum cryptocurrency or Ether with this function call, okay? And what we do is we take the NFT, all right, and then we, just cast it to an address payable type. All right, and then we call self-destruct and we pass in the NFT address. So what's going to do, let's say the attacker sends in 100 Ether and they call self-destruct. Of course, it's going to, essentially erase this smart contract for lack of a better word, but it's going to force send all the Ether that just got sent in with this transaction that will now be, contained inside the smart contract to the NFT address. So what's that going to do? Well, when they send in 100 Ether, it's going to essentially make the Ether balance at least 100 Ether here. And so it's going to essentially break this minting functionality because we're tracking the goal here. We're making sure that the amount of Ether in the smart contract is less than the goal, and the attacker just sent this amount of cryptocurrency over the goal here. So it's going to no longer let people mint NFTs inside of this, okay? So I'm going to essentially illustrate this in the test so that you can see how it works and you can play around with your own scenarios where you might attack a smart contract with self-destruct, but I'll illustrate it right now. So essentially what we're going to do is use this skeleton here. Inside of here, I've just got some helpers pulled in that basically converts, tokens into way values. Okay, we got ethers pulled in here. We've got chai for our tests, and we have a simple describe function. It's called, we're going to describe self-destruct, and then we're going to say describe the vulnerability, and we'll have one test example that just says it forces ether into the contract and it breaks minting. So inside of the inside the test, what we're going to do is set up some variables here. We're going to store the NFT contract into a variable so we can access later in the test. And we're going to store some different counts to variables as well, like a deployer, collector who's going to mint some NFTs, actually 3 collectors, 1, 2, 3, and then the attacker who's going to call the transaction to break the NFT minting. Okay. So the first thing we're going to do is get that NFT deployed. Okay. So we're going to say const NFT equals await ethers get contract factory NFT. All right, it's going to pull it directly from this file here from the artifacts inside of Hardhat. Okay, and then we're going to deploy it and save it to a variable lowercase NFT, and then we're going to set up some accounts with ethers.js. Okay, we're basically going to paste these in here. So we say let accounts equals await ethers get signers. That's going to pull in all the accounts from Hardhat, and then we can just assign them to individual variables here, like the deployer, collector 1, 2, 3. And then also the attacker. And we just read these out of this array that's given to us from ethers and Hardhat. And then finally, we're going to deploy the attacker contract like this. So we'll say const attack equals ethers get contract factory attack. And we deploy it and save it to a lowercase attack here. And both of these contracts are saved, in these lowercase variables so we can access them in the test. So now let's illustrate the vulnerability. Let's save some variables at the top of this so we can use them in our test. We'll say let transaction and result. We're going to reuse these. So the first thing we're going to do is have a scenario where collector 1 right here, all right, mints an NFT to prove that it works, all right, before we break it. So basically we're saying collector 1 mints a token, and we say transaction equals await NFT connect collector 1 that connects collector 1's wallet to the NFT contract with ethers. We call the mint function, and we pass in a value for this transaction of ether 1. All right, again, we have our ether helper up here that we saved into the file. So then we just wait for that transaction to finish, and now we can check for a few things inside the test to make sure that it worked. Basically, the NFT owner of, which we're tracking our contract, should equal the collector 1 address. And then the balance of the entire smart contract, so ethers provider get balance NFT address should be equal to 1 ether. So let's just run that test really quickly, make sure it passes. We can go to our terminal here and do npx hardhat test. Okay. And let's just see. Yeah, it passes. Awesome. So let's continue on here. We're going to do the same thing for collector 2. All right. So we transaction await NFT connect collector 2 mint value ether 1. Okay, transaction wait. And then basically we're going to check the ownership that they got it, and that was equal to collector 2's address, and that the contract balance is now 2 ether. All right. Run that test, see if it passes. All right, we're good. Now we're going to attack the smart contract from the point of view of the attacker. So we'll say let transaction equals await attack. This is the smart contract. Connect attacker, this is the wallet, and say attack, which is the function on the smart contract. And we pass in the 100 ether. All right, then do await transaction wait. All right, and then we say expect that the contract balance is now 102 ether because we've collected 1 ether from each of the collectors, and then we've sent in 100 ether from the attacker's perspective. So let's just check that, make sure it works in the tests. And boom, it passes. And then finally, now that the attacker has broken the smart contract and forced 100 ether into it, we should see that they are now no longer to mint NFTs. So basically, we can say await expect NFT connect collector 3, who has not minted any NFTs yet, call the mint function value 1 ether with the appropriate amount, and we can expect that this transaction is going to be reverted. So let's check that in the test. And boom, it passes. All right, so that's an overview of how you can hack smart contracts with the self-destruct function. So I hope you liked this video. As always, smash that like button down below for the YouTube algorithm. Subscribe to this channel if you haven't already. If you like this videos and you want to see more videos just like this, you can go to my YouTube homepage. You can find those free courses there. They're like Udemy courses, but they're totally free. By now, we should have a special playlist there for hacking smart contracts. Now that we've created several videos just like this one, okay, so you can check those out. And if you like those videos and you went to the next step, or hey, maybe you want to take a master shortcut entirely, I can show you how to master blockchain step-by-step from start to finish over at dappuniversity.com/bootcamp. You don't need to be an expert to get started today. I've helped people with zero coding experience become real-world blockchain developers in a matter of months. So that's all I've got. Until next time, thanks for watching Dapp University.